All right, we're just going to continue multiplying polynomials. And what we focused on last time, all right, was binomial times binomial. So all we're going to do now is expand that, all right, to like when I have a binomial times a trinomial, maybe even a trinomial times a trinomial. So binomial means two terms, all right. So for example, this is a binomial right here, x plus 1 and 2x minus 3, right? So just going to expand on that a bit. So just to get you kind of thinking about that, all right, go ahead and do the three problems in our opener here, flip it back on, and we'll see how you did. All right, so you can see my work here, and I went ahead and just used the area model, all right, to set everything up. So hopefully on problem one here, you got 2x squared minus 1x minus 3. On our second problem here, hopefully you got x to the fifth minus 2x cubed minus 3x. And then notice once again, we want to go in descending order, so you may have to kind of look around, find that highest power of x. All right, and then remember, x minus 1 squared means x minus 1 times x minus 1. So x minus 1 times x minus 1, hopefully you got x squared minus 2x plus 1. So hopefully that all seems very familiar to you. So the good news about today's lessons, it's really just the same thing that we did last time. Now, this is where the area model really does help, because if you try to distribute, all right, and set it up in the other way, sometimes terms get lost. I like this because it really helps you kind of keep track of all the terms. Now, how do you know how many boxes you need, right? So notice when I look at number one here, I have a two binomial, so a two term times a trinomial, which is a three term. So that means I need a 2 by 3 box, right? So here's my 2 by 3 box right there. All right, so knowing, all right, how many terms you have helps you set up the box. And then I have x plus 1 here, x squared plus x plus 1. And you could have gone the other way. You could have had the 3 going down and the 2 at the top. You'll get the same answer in the end. All right, and now you just go and start multiplying, right? So x times x squared is x cubed. X times x is x squared. X times 1 is 1x. All right, 1 times x squared is 1x squared. All right, 1 times x is just a 1x, and then 1 times 1 is 1. Now, the reason I like this, and if you do this and put everything in descending order along the top and descending order along the side, then your like terms, all right, more than likely will be on the diagonals as long as you don't have any powers skipped in there. All right, so x cubed, only term with an x cubed in it. And then I can see that my x squareds are along this diagonal. So 1x squared plus 1x squared is 2x squared. And then 1x plus 1x, all right, that would be 2x. And then I only have my one number here, so that's plus 1. And there's my answer. All right, and that's all it is, right? So it's really just a repeat of what we did in our last lesson, all right, just with more terms to multiply. All right, so once again, on number 2 here, I have a binomial, two terms, times a trinomial, so I need a 2 by 3 area model. So here's 2x minus 1, negative 2x squared, plus 3x, and minus 5. And then once again, we just start multiplying. 2 times negative 2 is negative 4. X times x squared is x cubed. 2 times 3 is 6. X times x is x squared. 2 times negative 5 is negative 10. And then I just have my single x right there. Negative 1 times negative 2 is a positive 2. And then I have my x squared right there. Negative 1 times 3 is negative 3. And I have just that 1x. Negative 1 times negative 5 is a positive 5. All right, and then now once again we want to look for those like terms. All right, there's my highest power of x is x cubed again for this problem, and it's the only term, so I'm going to bring it down. Then I have 2x squared terms along this diagonal, so 2x squared plus 6x squared is 8x squared. Negative 3x and negative 10x gives me negative 13x, and then I have my plus 5 right there, and I just bring that down. And that's all we have. All right, let's move to number, all right, 3 here. All right, 2x squared plus 1, all right. And notice now on this one, I skipped a power of x. That's what I was referring to earlier, right? So we're missing a power of x here. So my like terms may not be on the diagonal, so just be aware of that. Now in my trinomial up here, x squared minus 3x plus 4, I don't skip any powers of x. All right, so now 2x squared times x squared is 2x to the 4th. 2x squared times negative 3x would be negative 6x cubed. 2x squared times 4 is 8x squared. 1 times x squared, that's just 1x squared. All right, so you can see now, notice, right, because I skipped that power, my like terms are not on the diagonal. All right, and then now 1 times negative 3 is negative 3x, and then 1 times 4, all right, is positive 4. Now, if I start with those highest powers of x again, I have an x to the fourth, and that's the only one, so I'm going to bring it down. I have an x cubed. There are no other x cubes, so I'm going to bring it down. Now, I do have two x squared terms, right? So here's an x squared term, and here's an x squared term. So they're not on the diagonals because we have a power that's missing in this particular polynomial. So now 1x squared plus 8x squared is 9x squared. And then I only have one power of x, or one term with a power of just 1 for x, and then my constant term, which is just a 4. All right, and so there's my polynomial at the end. All right, now looking at number 4 here, notice now I have a trinomial, which is a 3-term polynomial, times another trinomial, which is a 3-term polynomial. So that means I need a 3 by 3 box. All right, and so here's x squared minus x minus 1. Notice I'm not missing any powers, descending order. Okay, x squared plus 3x minus 5. Descending order, not missing any powers. So hopefully all my like terms will be on those diagonals now. All right, so x squared times x squared is x to the fourth. X squared times 3x is 3x cubed. All right, x squared times negative 5 is negative 5x squared. Negative x times x squared, that's negative x cubed. Negative x times 3x is negative 3x squared. Negative x times negative 5 is positive 5x, I should say. Negative times negative is positive. All right, now negative 1 times x squared is negative 1x squared. Negative 1 times 3 is negative 3x. Negative 1 times negative 5 is a positive 5. And now you can see that those like terms are now back on that diagonal, all right, because we have everything in descending order and we're not missing any terms. I have 1x to the fourth term, so let's bring that down. Here are my 2x cubed terms. So negative x cubed plus 3x cubed would be a positive 2x cubed. Now I have 3x squared terms along the diagonal here. All right, so negative 1 plus negative 3 plus negative 5, that would be negative 9x squared. And then negative 3 plus 5 is a positive 2x. And then I have my one constant term, which is a plus 5 right there. All right, so let's go ahead and flip the page. All right, let me pause it here. Let me find my other page. All right, it was hiding under my desk. All right, so we're going to do, all right, one more problem here. All right, and so what I'm going to do is just have you do problem 5. So I want you to fill out your area model, do the problem, and then flip the video back on, and we'll see how you do. So go ahead and do that right now. All right, so I have 2x squared minus 4x plus 1 along the top. And notice in descending order, not missing any powers, x squared minus 4x plus 6. All right, in descending order, not missing any powers. So hopefully your 3 by 3 box looks something like mine. All right, and then as you go through and look for your like terms, we have that 1x to the fourth term. Then we have 2x cubed terms here, so hopefully you got negative 12x cubed there. We have our 3x squared terms right here. And if you add all 3 of those, hopefully you got 29x squared for that. And then you have your 2x terms here, so that'd be negative 28x. And then you have your one constant term at the end there, which is plus 6. All right, and so that wraps up our video with more multiplying polynomials. So you can see it's really a lot of the same stuff, just more terms. All right, as always, if you have questions, make sure you have those outlined, all right, or written down, highlighted something. We'll ask those in class, and we'll see you then.